in this universe where there is this non-dimensional tower. Now, what happens here is that this electron is guided by this tower. Its distance is constant, and its motion is guided by what we call as spherical harmonics. And the spherical harmonics guide the motion of this electron and leading this electron to have distributions in the three-dimensional space. So if this particle is guided by this tower, which is at the center, then this potential that's acting on this electron is centrally symmetric potential. So what we are doing here is we are boiling down a very complicated three-dimensional problem into two frameworks. The framework of how far this electron is from this center, or what you call this tower, and how the spherical harmonics are guiding this electron to make the clouds around this tower. And what we can say at this point of time is that this guiding of electron to form the clouds around the tower is all coming from the symmetry. The action of the tower on this electron is symmetrical in nature. That's why the center potential problem is always treated as a symmetrical action to realize a three-dimensional problem. So the spherical harmonics that are acting on this electron forms what we call as orbitals, and the shapes of these orbitals are guided by what we call as the spherical harmonics. And in contrary to the quantum mechanical central potential, we have classical central potential. And in classical